What was the Euclidean distance? Euclidean distance, the straight line distance between the 2 points in Euclidean spaces. I show you the example from sci-fi, CIPR dot spiritual, spiritual dot distances board EDC Euclidean. I taken the 2 points. The point 1 is equal to, so 1 comma 2, and the point 2 is equal to something. There's a 4 comma 6, and this is one thing. The Euclidean distance or the Euclidean function has required the 2 points. This is the print. Euclidean distance, and then we have the text. See, ULIDA. Like we use where we use them using in a clustering like a k-means clustering, image regression, and the basic distance between the calculation. As a basic distance the calculation, sometimes you have to using the real scenarios finding the Euclidean distance. We can creating a movie app, and then we use the Euclidean distance to find the which was the similar movie without using the machine learning. Like Euclidean distance we can't but Euclidean distance is one of the easy way to get the similar movies or similar things like this. For example, you can, I told you this previous, we can using in a k-means clustering and use the Euclidean distance. K-means need the k nearest or the k-means is finding the nearest neighbors using the Euclidean distance, and the image recognition, that's find the similar images using the Euclidean distance, and the basic distance between the calculations. And then this is the cosine similarity. COSINE. The cosine similarity. The cosine similarity is a measuring the cosines of the angles between the two vectors, including their orient similarity. Sorry, the measuring of the cosine of the angles between the two vectors, including their orientational similarity. For example, I show you the from a scalar matrix, so pairwise both cosine similarity vector 1. Vector 1 is equal to np dot array, and we call as a vector 1. The two functions 1 comma 0 comma 1, and dot reshape 1 into 1, 1 into minus 1, and the cosine similarity. Solution and the cosine similarity. This is a similarity. The cosine similarity is most of the cases in commonly in the text analysis and recommendation systems compared between the document similarity. And then we have Jaccard similarity. Jaccard similarity is a set of compromission, like a comprehension, the finding the common between the overlapping search results or tags. Example, image searching, comparing binary masks and the object detection. Example, intersection or the union. And then clustering means a similar between the categorical or the binary data points. Useful from the categorical or the sparing of the binary data. This is a similarity. Has some distance. The Harrison distance, geographical systems. Like most of the times, we use the geographical systems, calculating the strong shortest distance between the two locations on the Earth. Example: GPS systems are route planning, and the logistic transportations using to optimize the routes for the calculating the traveling the distance. According to the Earth of the spatial shape, providing the accurate distance of the globe. Uh, according for the Earth spatial shapes, providing the accurate distance for the global coordinates. This is okay. I think there is no harvest. We need to install that. The distance, harvest and distance get output is get the distance, and then and the hamming, hamming distance. From sci-fi spiritual dot distance hamming string one. So having distance error detection and the error detection and correlations checking from the different binary codes, example partial check, sorry, example or sorry, data mapping, comparison binaries or categorical strings, example in networking or cryptography, measuring the abstract difference binary useful for discrete comparisons. And then we have the Manhattan distance. What was the Manhattan distance from sci-fi dot spiritual distance? Okay, it's automatically detecting you with that. It's a grid based. Uh, it's a grid based pathfinding, calculating the distance between the in cities like grids. Example: taxi navigation in the future spaces using the higher dimensions in the data. Just where the straight lines of the distance isn't suitable. It's and the neural networks used in the L1 regression to enforce the sparsity in the weights is better suitable. The distance is it is a better suitable for the problems with the grid like or the higher dimension spaces. Next we have the Canberra. Manhattan Canberra is a weight version of the Manhattan distance. It is embarrassing of the smaller distance, useful in the cases where the small changes are important. Generally, it's similar to the Manhattan, but when you are using the weights, all weights are most like where the dealing everything is important like weights. You can use the Canberra distance. Then hit enter. The Canberra distance is 1.1. Both are the similar. You see, you can see them. The previous one, the previous one has a 7 Manhattan distance, and you using the calculating the weights also, it's changes like the 1.1. Then we have the Minkowski distance. General distance can be adapted to problems where the either Euclidean distance or Manhattan distance is required by distance p as a p-value. The clustering and useful distances like clustering and classification use the flexible matrices for the different data distributions. Is a 5-point distance Minkowski distance. Use the flexible matrices difference between the distribution. Allow the customization of the distance computation by the parameter of the p. And then we have the Chebyshev distance, the chessboard problem. Determine the number of moves for the king takes the chessboard. And industrial automations. You can use also a Chebyshev distance industrial automation, measuring the maximum deviations in any dimension for the quality control and routing. Ensure the maximum dimensions constraints and or meet in the delivering network. The Chebyshev distance is 4. Using the maximum range of the constraints, is uniform the measurement of the these are 1, 2, 4, 6. The distance is 4 still. And then we have the Sorensen dice coefficient. It's not like that. There's another option, but receptor. That's fine. Didn't use the dice. Nice. Sets and dice coefficient on the useful in the text and image analysis. Find the similarity between the set of words. Example, parallelism, the detection of the or image regions, and biological data when you overlap the in DNA or ports and sequence datasets and the clustering. Determine the similar categorical or spared datasets. Right, and let's give the dice is 0.4. Sorry, it's emphasize the shared elements over the total size, making it a invental of overlapping sensitive applications. Session dice. How can use the right matrices? Like showing the example. If you have the continuous data, use the equivalence or Manhattan distance, or the categorical or the binomial. Sorry, it's a categorical or it's a categorical or binary data. Use Jaccard or Hamming or Sorcian, Sorcian dice. And the text or vectors use the cosine similarity, and geographical data use the Harman distance. High dimension data consider as a Minkowski or Manhattan distance, and the spared data, Jaccard or the cosine similarity work best. These are the use cases. Those are the most use cases. Right matrices. You choose the right matrices for the right problems. They get the better values. These are the values.